We're going to graph a rational function with a table. You'll also see transformations happening today. Should mention that. It's kind of in the title. Exploring rational functions with transformations. Okay, so it's like a double whammy. You'll be learning about rational functions and some of the characteristics, as well as transformations that happen on those functions. And the general equation, right? If I started with a base function y equals 1 over x, the general equation for a transformed function would be a over b times x minus h plus k. And a, b, h, and k all do the same thing they've been doing all along. A controls the vertical stretch, b the horizontal, h the horizontal translation, k the vertical. Right? This should be pretty familiar by now. I'm not going to spend too much time on it. Okay, so we've got this function y equals 10 over x. Okay, right here. What transformations are taking place in comparison to y equals 1 over x?
Vertical stretch.
Yeah, there's a vertical stretch by a factor of 10. Yeah. So all the values are being multiplied by, all the y values are being multiplied by 10, sorry. Okay, so let's just think of this for a second when we generate this table. If x was negative 10, what would the value of y be? So if x was negative 10, what would the value of y be in 10 over x? Negative 1, right? You have y equals 10 over negative 10, which is just negative 1. Right? If x was negative 5, you would have 10 over negative 5, which is negative 2. Right? The choice of x, the negative 10, negative 5, negative 2, and so on, the choice of x is determined by things that 10 is divisible by. So you could do like negative 3, negative 2, negative 1, 0, 1, 2, 3 for your values of x and create your table that way. But you would end up with a bunch of funny fractions and decimals. So it's a lot easier to just choose values of x so that 10 is divisible by those values. Okay. So just finishing this up here, this would be 10 over negative 2, which is negative 5. 10 over negative 1 is negative 10. And then we have x is 0. What would the value of y be there?
0.
Undefined.
Undefined.
There would be an asymptote there, yeah. Okay. And then we go back up from 1. So this is 10 over 1 is 10. 10 over 2 is 5. 10 over 5 is 2. And 10 over 10 is just 1. So we've got some points that we can plot, and we'll get an idea of what this graph looks like based on those points. Okay, so let's plot them. We'll graph first negative 10, negative 1. So that would be here. And negative 5, negative 2. So that would be there. Negative 1, negative 10. There. There's an undefined value at 0, so there's an asymptote there. We'll draw that in a second. 1 and 10, so that'd be up there. 2 and 5, so that's there. And 5 and 2. Did I miss a point? 10 and 1. I feel like I missed a point. Negative 5, yeah, I did. Negative 2, negative 5. I thought so. Negative 2, negative 5. There we go. So you have a general idea of what this graph looks like, right? It's coming in from the left. I'll use a thinner line. And going down, and then it's coming in from positive infinity, and then swooping down and going out. Okay? So it's broken into two pieces. And like we said before, or like we noticed in our table, there's an asymptote right on the y-axis. Okay, because you can't divide by 0. So that would be a vertical asymptote because it's going up and down. Would there be a horizontal asymptote?
Yes.
Yes, where?
On the X.
On the x-axis. And you may not remember, but when we were doing grade 11 math, we were only concerned about vertical asymptotes, and we didn't talk much about horizontal asymptotes. I'm going to spend some time today trying to explain horizontal asymptotes because they're a little bit different than vertical, especially finding them, other than just kind of looking on your graph and being like, I think it's about here, which is a really bad way to do graphing. Okay, I'm going to show you some formal-ish ways of finding the vertical asymptote.